This is experiment 16 from Human Physiology with Vernier. This uses the hand dynamometer sensor, and we're going to do it with the LabQuest. So once I connect the sensor into the LabQuest, the software automatically identifies that the hand dynamometer is connected and gives me a live readout of the force reading. What the hand dynamometer measures is grip strength. In this activity, we compare grip strength of one hand versus another. In the real world, grip strength is an indicator of neuromuscular functions used a lot by orthopedic surgeons and physical therapists, either to measure the extent of an injury or recovery after an injury. It's also used in sports medicine as an indicator in things like football, tennis, almost anything where you use your hands. Grip strength can be an important indicator of your progress in training. I should mention though, as with all Vernier products, this is designed for educational purposes only and should never be used for patient diagnosis or real-world medical data. In this case, the software set itself up to do a graph for 60 seconds, but this particular activity calls for a graph of only 10 seconds. So to change it, I just tap on the word length and then change the experiment length from 60 to 10 and tap OK. Before I begin the run, I want to zero the sensor. What I need to do is just hold the sensor in the same orientation I'm going to be using it, and then tap anywhere in the red portion and select 0. And that just defines the current setting as 0 newtons. To begin the run, I just tap the collect button. I'll see a real-time graph of force versus time. I'm going to let it run for a couple of seconds, then I'm going to go ahead and squeeze with my right hand as hard as I can for the rest of the run. And now when that ends, what I want to do is store that run and then compare the right hand strength to the left hand strength. So what I'm going to do is store this run, and the way we store the run in the software is to just tap the filing cabinet icon. And now we're going to start a second run by just tapping collect again. We'll let it go for a couple of seconds, and then I'm going to squeeze as hard as I can with my left hand for the duration of the run. To see both traces at the same time, what I'm going to do is go into the graph menu, select Graph Options, and then select both Run 2 and Run 1. And then I tap OK. Now I can see an overlay of the first run compared to the second run. Notice that the software has color coordinated the runs for me so that my first run is in red and my second run is in blue. And you can see right away that we've got a significant difference in the total grip strength between the first run and the second run. To put a little bit of a finer point on the analysis of it, what I can do is just select the region of the screen when I was squeezing the sensor, go into the Analyze menu, and choose Statistics, and I want to select both my second run and my first run. Over at the right, I've got a readout of the min, the max, the mean, the standard deviation, the total number of samples for each of those two runs. The value that I'm most interested for this particular one is the mean, which is the average applied force. And you can see there is a value for 168 for run 2, and in run 1 my mean was 265. That much of a difference would indicate a dominance in the right hand, which, since I'm right-handed, makes sense, and I have better strength in my right hand than my left. For the second part of this activity, what we do is, instead of compare one hand to another, we're going to compare pincer grip strength. So on the same hand, to compare how hard I can pinch between thumb and different fingers, what we're going to do is go into the File menu and select New. I'll be asked if I want to save the data. Typically you'd have the students write down the values, but in this case we're just going to discard it. And then again, it's auto-identified the sensor, but instead of doing a run for 60 seconds, this time I'm going to change the duration of the experiment by tapping length again and changing it from 60 seconds this time to 20 seconds, because we're going to be comparing pincer grip strength of the different fingers. Again, before I begin the run, I tap anywhere in the red region and select 0, and that defines my current setup as 0 newtons of applied force. Then to begin the run, I tap collect, and I get a graph of force versus time. And I'm going to start with my pinky finger and grip as hard as I can for a couple of seconds. Then I'm going to switch to the next finger and the next finger And lastly, I'm going to do my index finger. At the end of the run, the software will auto-scale so that we can see the graph of force versus time for only where data appeared on the graph. If I want to see what the value is for each of the fingers, I can tap to get a live readout at any individual point, or I can do what I did before, select the region, go into the Analyze menu, and choose Statistics for that force value. And I'll see my mean over here, and I can repeat that for each of the 4 fingers. We can see right away from looking at the graph that we went from the lowest peak force to the highest peak force as we got closer and closer to the thumb, which would indicate that those bigger fingers that are closer to the thumb will give us better pincer grip. In the lab activity, we also compare different variables, including gender, right-handedness versus left-handedness, frequency of physical activity, height, weight, and you can add in lots of different variables. One of the most popular changes to this lab actually that people do is to make it into a competition, to make it a grip strength contest. Particularly with teenage students, anytime you can make it into a competition, the students are almost always more engaged.